Okay, in the last video we have studied the oxidation reduction, oxidation number, how to calculate the oxidation numbers, and what are oxidizing agent, what is the reducing agent, right? And these things we have studied, and in the next video we will study the what part of the reaction oxidize, then what part of the reaction get reduced, and then we will go to the metal activity series. That's a very important metal activity series, and you will learn there what reactions are possible, what oxidation reduction reactions are possible, what are not possible, which element can reduce which one, and that's very important. So metal activity series also you will learn there and see there, and then finally you will calculate the heat of reaction. So heat of reaction you will calculate using the chart, or that's the table of the heat of reactions. That's we will use the enthalpy of the reactions we will give you the value of the. So this video you will study that. And is the reducing agent. What get reduced is the oxidizing agent. Okay. So other is oxidation number. We see that increasing the oxidation number is oxidation, decreasing the oxidation number is oxidizing agent. Okay. If it get oxidized, it is reducing agent. Now let's take one example. Oxidizing agent. Okay, so this is one, but now let's see one example here. 2AlS plus 3H2SO4 gives you Al2SO4 whole thrice plus 3H2. Yes. So now let's see that aluminum here is 0, right? All elements have the oxidation number 0. That's why aluminum, so the aluminum oxidation number is equals to 0 in this case, left hand side. And right hand side, what is the oxidation number of aluminum? SO3 is, let's say, let me calculate that. Okay, Al2SO4 whole twice. Okay, so Al2, let's say aluminum is X, then it is 2X plus SO4 has minus 2 charge, right? SO4 has minus 2 charge, but you have 3 SO4s, that's why 3 times 2 minus 6. And the SO4 S is 6, right? Because it is S2SO4, right? Yeah, see, S is 6. So oh no, let's see that S2SO4, yeah, 2 plus 2 minus 8 is equals to minus X. So yes, 6. Okay, so now here aluminum, let's see the aluminum here. Aluminum is 2X is equals to minus 6. Okay, so that's why it is aluminum is 3 plus 3. So 3S2 is 0, 0, 0. That's why we can do like that. Sample problem. Now let's see some problem. Okay, identify redox reaction and oxidizing and reducing agent. You have to identify whether something is oxidation reduction reaction or not. Okay, how do you find something is oxidation reduction or not? Because if any one of the species increase or decrease the oxidation number, that is the oxidation reduction reaction. Okay, so if the increase or decrease of the oxidation number, that is the oxidation reduction. If nothing can increase, no any element have oxidation increasing oxidation number or decreasing oxidation number, then that is not the oxidation reduction reaction. Okay, let's see these 3 examples in our solution, and then you can realize that. So 2 aluminum, so you see 2 aluminum S plus 3 H2SO4 gives you SO4 whole thrice plus 3S2. So this is the redox reaction, because aluminum has what? 0, and aluminum has, how much is here? Plus 3, right? Aluminum has plus 3. Done. It is oxidation reduction reaction, because 1 is increased. No need to see everyone, but you can see that. That's good. Hydrogen has plus 1, right? Hydrogen has 0. See? Okay. So sulfur has plus 6. This sulfur has plus 6, and the sulfur here has plus 6. Oxygen is O4 is here, so Oxygen has -2. It has also -2. Right? So all others are same, but hydrogens and the aluminum increase and decrease, right? So that's why this is oxidation reduction reaction. So now let's say other one, H2SO4 plus NaOH gives you Na2SO4 plus 2S2. Now if you see that here, each atom has same oxidation state, left hand side and right hand side. So S2, hydrogen has +1, you know, hydrogen has +1, sulfur has +6, oxygen has -2. Okay. So sodium has, you see that sodium has +1, oxygen has -2, and hydrogen has +1. So sodium has +1, sulfur has +6, oxygen has -2, hydrogen has +1, and this has -2. These are the all assigned oxidation number we have assigned. Okay, this if you find out this, look at that, hydrogen +1, here is also hydrogen +1, no change. Sulfur is +6, sulfur is +6 here, sulfur has also no change. Oxygen has -2, here is oxygen has also -2, all the oxygen has -2, no change, right? This is no change. Sodium is +1, sodium is +1, no change. Oxygen is -2 again, oxygen is -2, no change. Hydrogen is +1, hydrogen is +1, hydrogen here is +1, right? So that's why no any oxidation number either increase or decrease. That's why this is not the oxidation reduction. In the oxidation reduction reaction, at least one species has increase or decrease in the oxidation number. Okay, so that is, so in this case you see that in this case lead is +2, sulfur is +4, see, so sorry, that lead is +4 here, lead is +2 here. Yeah, oxidation reduction reaction, at least lead has increased, means that it is oxidized. Okay, and this carbon is reduced because carbon has +2 here and carbon has -2 here. So okay, I think no, that's, so let's see that. Okay guys, now let's see the another example. So let's see the another example, that is PbO plus CO gives you PbS plus CO2. Okay, so in this side, in the reactant side, its oxidation number is +2 and its oxidation number is -2. Carbon's oxidation number is +2 and its oxidation number is -2 in this case. So in this side, in another side, let's go to the another side. So on the side, Pb is 0 here because, so Pb is just the solid, right? It's nothing, it's the element. That's why. So now let me write clearly. Okay, Pb is now sulfur, this is S, solid. So this is the metal, that's why it is 0. Carbon has +4 here and oxygen has -2 here. Now let's see that what is happening. This is decreasing, +2 to 0, means it's reducing or reduction of the Pb. Okay, so the lead, reduction of the lead is here. So this is oxidizing agent. So but the oxygen, if you see that, what happens to oxygen here? If you see that CO, let's pick out the C. Carbon is +2 here, carbon is +4 here. Oxygen is -2, no change. But the carbon is, look at that, carbon +2, carbon +4. Carbon +2 to +4 means it's increasing, means it is oxidation. It means it is a reducing agent. Okay, that is the oxidation reduction. Okay, so now let's see some activity series of the metals. Okay guys, Metal has activity, means you have seen the previous reactions. Some one thing is reducing another thing. Itself get oxidized and other it get reduced. Make the reduction of others. Okay. So if you see that the previous case, one example, aluminium plus H2SO4 sulfuric acid gives you Al2SO4 whole thrice plus 3H2. So if you see that the aluminium is 0 here, aluminium is plus 3 here, right? It's the plus 3, aluminium has plus 3. That's why aluminium has plus 3. It means the aluminium is oxidized, right? Oxidation means, so gain of oxidation is the loss of electron, right? So oxidation is the increasing the oxidation number, reduction is the decreasing the oxidation number. So but it is the increasing, right? 0 to 3 increasing means this is oxidation of aluminum, and the reduction of sulfur. So reduction of hydrogen, actually sulfur is the same, 6 here, 6 here, all same, but the hydrogen, reduction of hydrogen. So that's why aluminum is a reducing agent. It reduces hydrogen, it is oxidizing agent. Okay. So but we see that aluminum can reduce hydrogen. What? Aluminum can reduce hydrogen? How? And why? Can reduce copper or not? For previously we were looking at zinc, right? Zinc plus CuSO4, and it is also doing that. ZnSO4 plus copper. So what is doing here? It is 0, it is plus 2, right? So zinc was oxidizing and copper was reducing. This was happening, right? Zinc was oxidizing, means zinc can reduce copper here because it is a reducing agent, right? It is a reducing agent, right? It reduces something because it oxidizes itself, means it reduces other. Okay, so it is a reducing agent. So that's why zinc can reduce copper. But can copper reduce the zinc or not? Is that possible? Cu plus ZnSO4 gives you zinc plus CuSO4? No, look at that. There is no reverse direction reaction. It cannot. Why? Why zinc can reduce but copper cannot? Zinc can reduce copper but copper cannot reduce zinc. Why? Or I don't know. It can be done or not. Now let's see here. Zinc can reduce hydrogen. Look at that. What was happening is aluminum can reduce hydrogen, zinc can reduce copper, right? Now let's see in this activity series, zinc is here, right? And hydrogen is here, copper is here. Okay, zinc can reduce copper, zinc can reduce hydrogen, but copper cannot reduce zinc. I say you, copper cannot reduce zinc. Okay, this is the series. This way we have the series, that is the activity series, because the zinc of activity of the zinc is more than the copper. That's why zinc can reduce. But whatever the upper ones, means that which is the largest, which is the highest reducing, means that can reduce everything. That is the lithium. Lithium can reduce potassium, beryllium, okay, barium, calcium, sodium, magnesium, aluminum. These all lithium can reduce everything. Potassium can reduce everything below that. Gold cannot reduce anything. Look at that. At the bottom of that, gold cannot reduce anything. Silver can reduce gold. Hydrogen can reduce copper. See, look at that here. Hydrogen can reduce copper. Copper can reduce the mercury, right? So nickel can reduce this, lead, like that. So calcium can reduce these all. Aluminium can reduce zinc. Zinc can reduce chromium. Zinc can reduce even the iron. Zinc can reduce cadmium. Zinc can reduce cobalt. These are the metal activity series. Okay. So in this way, from this series, you can guess which can reduce which and which reaction can occur and which reaction can. Now let me see that one thing. Okay, K2SO4 plus zinc is zinc SO4 plus K2 or 2K, sorry, 2K, because it's a metal, right? Potassium metal, alkali metal. Okay, 2K. If this reaction can happen or not? No, because look at that zinc. What is the oxidation number here? 0. What is oxidation number here? +2. Zinc is oxidized. Oxidized zinc means it is a reducing agent. Okay, but in this case, look at that K2, potassium. What is the potassium here? +1, right? Potassium is also always +1. Sodium, potassium, +1. What is the potassium here? 0, right? So it is decreasing, means it is a reducing. It reduced means it is oxidizing agent. So it means that zinc is reducing what? Potassium. But look at the activity series. What is the above that can reduce the below one? So lithium is above than potassium. Lithium is higher than everyone. That's why lithium can reduce everyone. Potassium is higher than everyone. That's why potassium can reduce everything. Okay. Aluminum is higher than everything. That's why below that aluminum can reduce manganese, zinc, chromium, but aluminum cannot reduce magnesium. So but that's why that reaction is not the oxidation reaction. So it don't happen. It don't reduce. So this is the activity series. Okay. So activity series of the halogen. If you think about the halogen, which halogen can reduce which one? See, fluorine is the highest reducing agent in the halogens. Fluorine, chlorine, bromine, iodine. But the reactivity increases up. What is the highest? Highly reactive? Iodine. Then bromine. Reactivity. Okay. Then chlorine. Then fluorine. So chlorine can oxidize bromine and iodine. So but the activity series is the oxidation. Okay. Chlorine can oxidize bromine because chlorine is above bromine. That's why chlorine can oxidize bromine. And bromine can oxidize iodine only. Fluorine can oxidize chlorine. So halogen series, you have not the reduction. It is the oxidation, right? You will see the oxidation. So fluorine can oxidize everything. Fluorine can oxidize chlorine means fluorine is oxidizing something, means it is a reducing, right? It gets reduced and it is oxidized others. So fluorine can oxidize all of them. And but chlorine cannot oxidize fluorine. Okay. Let's see. So now let's identify the types of the reaction. Let's identify the type of the redox reaction. Okay. So magnesium plus nitrogen. Look at that. Two things. Magnesium plus nitrogen giving you magnesium nitride. Right? One thing. Magnesium nitride. Right? So that's why magnesium nitride, it is combining one thing, magnesium nitride, right? That's why. So it is the combination reaction. So hydrogen peroxide to water and oxygen, H2O2, it gives you water, H2O plus oxygen, right? So this is the breaking down, means it is decomposition. So other is the aluminum plus lead nitride, right? Lead nitride, PbNO3 whole twice. Okay. So PbNO3 whole twice, and in this case, this gives you aluminum nitride. This is right, aluminum nitride. So that's why what is happening, it is displacing the lead. That's why it is a displacement reaction. So this is the displacement. It displaces another and just fit itself there. So that is okay. So that is the reaction is here. Do you see that? The reaction is here. ammonium plus Pb2 plus 6NO3, right? And because you are multiplying with this, and then that's why everything is there. It's just a fit itself there, and it displaces the another one. That's the displacement reaction. So now this is up to the oxidation reduction. Now let's go to the specific heat. We have studied the specific heat in last chapter at the beginning of the course. Okay, you remember that. Specific heat is the amount of heat necessary to raise the temperature of 1 gram of the substance by 1 degree centigrade. Okay, so that is the specific heat, and the amount of heat, and we studied this previously also. Amount of heat is equals to specific heat times mass times T2 minus T1. Okay, so for example, how many calories are required to heat 352 gram of water to this degree to this degree, right? This is the change in temperature, 95 minus 23 in change in temperature times the mass times the specific heat, because the specific heat is given 1 calorie per gram per degree centigrade. So that's why you calculate and get that specific heat. We've already studied that. Just repeat. But this is the heat, right? You know that. Specific heat times mass times the change in temperature. That is the heat. Okay. Heat is equals to specific heat times mass times the change in temperature. That is the heat. So, but the heat of reaction means how much heat is produced or consumed during the reaction. That is the heat of reaction. Okay. For example, CS plus O2, it gives you CO2 plus 94 calorie heat, cal per mole per degree centigrade. Oh, calorie per mole. Okay, sorry. That is the kilocalorie actually, kilocalorie per mole. Okay, so 95 kilocalorie heat it will give this reaction in 1 mole. Okay, so heat of reaction, the heat of given of the or absorbed, right? So either it takes heat or it gives heat, and that is said to be the heat of reaction. So that's why on the basis of either taking the heat or getting the heat or giving the heat, there are two types of the reaction. One is the exothermic reaction, that gives the heat, and endothermic that uses the heat, means that takes the heat. Okay, there are two types, exothermic reaction and endothermic reaction. Exothermic reaction means that produce the heat, and endothermic reaction means that uses the heat. Okay, so heat of reaction if calculated using change in enthalpy. So if, for example, if you calculate the heat of reaction using the change in enthalpy, then enthalpy of the product minus, then what you will do, change in enthalpy is equals to enthalpy of product minus enthalpy of reactant. That way you can calculate the heat of reaction or enthalpy of the reaction. So but if enthalpy of the reaction is less than 0, it is exothermic, and if enthalpy of the reaction, or it is also said to be heat of reaction, it's the same thing. Heat of reaction is greater than 0, that is the endothermic. That's why. So for example, endothermic and exothermic, how do you write? For example, H2O convert into, you have a H2O gas. H2O gas means the steam convert into H2O liquid, right? Gas has more heat, liquid has less heat. It means it has to lose the heat, right? It has to lose the heat. Gas to liquid, it has to lose the heat. That's why delta H negative. But H2O liquid to H2O gas, you have to give the heat, right? That's why heat will be here. So that's why how do you write those two equations? This is the exothermal, this is the endothermal, right? It will consume the heat, it will produce the heat. So thermochemical equation, how do you write that? H2O gas convert into H2O liquid plus heat. Its product is liquid water and heat. Its product gives the heat. And if you boil the liquid, H2O liquid, if it consume the heat, then it will give you H2O gas. So in this case, this is the endothermic reaction, heat is the product. Heat is the product. In exothermic reaction, in exothermic reaction, heat is the product. In endothermic reaction, heat is the reactant. Right? Heat is on the reactant side, that is in the product side. So if heat is produced, that is the exothermic reaction. So now let's calculate the heat of reaction. How do you calculate the heat of reaction? Okay, heat of reaction is equals to heat of reaction delta H, heat of reaction is equals to summation of F delta H product minus summation of N delta H reactant. That is the heat of reaction. So delta H product you will find from chart, delta H reactant you will find from the chart, and this is the stoichiometric coefficient. That is, these are the stoichiometric coefficient. For example, if you see that example, if delta H of KClO4 is this, right? KClO4 is this given here. Delta H of KCl is this, you see, and the delta H of KClO3 is this. Find the delta H Rxn of this reaction. Okay, what is the reaction? KClO3 gives you KClO4 plus KCl. So its delta H is given that this KClO3 is minus 397.7 kilojoule per mole, and its KClO4 is given is minus 432.8 kilojoule per mole. KCl is given minus 435.5 kilojoule per mole. This is given. Okay, so if that is given, now let's use this one and find delta H of Rxn. So first of all, let's see that everything is balanced. K, no, it's not balanced. You have to balance that. Now let's balance that. So when you balance, that is 4 gives you 3. This is the balance equation. Okay, now it means that delta H Rxn is what? Product minus reactant. Okay, what is the product? 3 times this, 3 times minus 432.8 kilojoule per mole. Remember that everything are kilojoule per mole. Okay, but if it is joule is given, you have to convert all the units in same. This is plus 1 times, its coefficient is 1, right? 1 times minus 435.5 kilojoule per mole. That is your product. This is the product. Minus, what is the reactant? Reactant is 4 times KClO3 is minus 397.7 kilojoule per mole. So product minus reactant. Okay, if you do that, you have this value. If you do that, now let me erase this previous one. Now let me erase this one. Okay. This value is minus 1734.9, and this value is minus 1590.8 is equal to minus 144.1 kilojoule. So this is the negative value, right? Delta H is less than 0, negative value. It means that it is endothermic. Sorry, it is exothermic. This reaction will produce the heat. Okay, how much heat it will produce? 144.1 kilojoule per mole. That's it for today. Okay, thank you so much. And we have studied at the end of the chapter, we have studied heat of reaction, that is the heat of product minus heat of reactant. If delta H is negative, it is exothermic. Delta H is positive, it is endothermic. If heat is produced, it is exothermic. It is consumed, it is endothermic. And we have studied the redox reaction, very important reaction. There, the redox reaction. Redox is reduction and oxidation reaction. Oxidation is the loss of electron, and reduction is the gain of electron. Oxidation means the increasing in the oxidation number. Reduction is the decreasing in the oxidation number. Okay, that is, we have studied oxidation reduction reaction. Okay, there are types of oxidation reduction reaction. Okay, one is the combination, decomposition, okay, displacement. These are the types of the oxidation reduction reactions. And we have studied the studied the metal activity series, right? So which has the higher activity that can reduce otherwise not. Okay, so we have studied this lots of topics in this chapter. Thank you so much. We will go to the next topic next day.